All right, today we are doing basically the same thing, except now we're just talking about what happens when you have different denominators, okay? They say unlike bases in here, but I don't really like to say that. I like to say unlike denominators. So anyway, if you're looking back in the day, and you had something like 1/4 plus, let's go with like 1/6, we needed to have common denominators. Now, 4 and 6, I'm hoping that you guys would say, oh, okay, let's make them both 12, right? How do we get from 4 to 12? We'd have to multiply by 3. So it means we have to multiply the top by 3. If we multiply the 6 by 2, we just have to multiply the top by 2. Again, just so that we'd have the same denominators, right? Now, one of the things, so when we get that, we would, now we can add them, and we just get 5/12 as our answer. So that's the one way of doing it, and that's kind of the easiest way. But if you're one of those people that's just like, I don't really, that really didn't jump out to me, what you can do, just try to erase some of this. Okay, you still would need like denominators, but sort of as like a fail-safe, you can always just multiply the denominators with each other, right? You get 24. Okay, what did I multiply the 4 by to get 24? That's just 6. So I'm going to multiply the top by 6 and the bottom by 4 to get 4 here. However, if you do it this way, again, it's a little easier to find what the common denominators would be, okay, just by multiplying them. However, when you add them together and get 10/24, obviously that's not what we got here, because what do we have to do? Okay, we need to say, oh, we can reduce this fraction by dividing by 2, and then we will get 5/12, which is what we had the other way. So you can either find the lowest common denominator, right, and then you would just get the answer, or you can find in just a common denominator, but then you would have to reduce the fraction. Okay, so it all depends on when you want to do the work. So that actually comes into play for this lesson. Even though it seems like it's pretty easy because it's just fractions, the concept is the same. It's just going to look a little different. So if I'm looking at these two denominators, I see 2 times x and 3 times x, all right? So what you could do, again, is either way that I just showed you with the just basic fractions. What I'm going to do is I'm going to find the lowest, because I think it's easier, and I think it helps you with, trying to figure out common factors and common multiples, all right? So when I'm looking at 2 and 3, I say to myself, okay, the lowest thing that, the lowest multiple of each from 2 and 3, if I multiply 2, I would get 4, then 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, right? These are just multiples. Okay, multiples of 3 would be 6, 9, 12, 15, so on and so forth. What's the lowest one that they have in common? Oh, that's 6, right? Now, you would never probably make these lists, but that is something that you could do. So that means the common denominator would be 6, and then notice that they both share an x, okay? So, okay, they both have a x in common, which means a common denominator would just have x. All right, really what you do is you take, the lowest multiple of the numbers, and then you take the variable with the lowest exponent, which for this one, they both have the same exponent. They both have 1. So it doesn't really matter for that one. So you might be a little confused with that part, because I think sometimes when the problem's so easy, it's kind of hard to understand what I'm saying. So let's look. Let's just try to finish the problem first, and then we'll get back to the whole exponent thing. So our common multiples were 6. And then for the exponents on the variables, right, our lowest one's 1, which again, we'll get back to at a harder problem. So how did I get from 2x to 6x? Well, I multiplied by 3, so I have to multiply the top by 3. And then how did I get from 3x to 6x? I have to multiply by 2. So I just multiply this one by 2, and I get 32. All right, now that they're common denominators, I can just subtract them, and I get 13/6x, and that is my answer. I am done. Okay, for this one, we're looking at our denominators, okay? Both different. So my first denominator is a squared. My second denominator is 8a, right? So what is a squared? A squared is just a times a. Over here, it's 8 times a. What do they have in common, right? So they have an a and an a. But what we're looking for is a multiple. When you're looking for, again, from that example that we had earlier, right? What do they both have in common here for 4 and 6 would be 2, but we're not trying to make our fractions, you know, denominator being 2. That wouldn't make any sense. You wouldn't be able to do that. So what we're doing is we're saying, okay, I have a squared and I have 8a. How could I make them the same thing? Well, you could just multiply them together and get a8 to the third. But again, like we did in the original problem, it's going to get a little confusing because then you'd have to reduce when you get to the end. So what I'm saying is if we're looking at a squared and 8a, I could make both of them 8a squared. How did I know that? Well, what you're going to do is you're going to look at a squared and say, okay, it's got a coefficient of 1. So a multiple of 1 and a multiple of 8 are both 8, a common multiple is what you're looking for. And then for the variables, you're just going to look for the greater exponent, okay? The greater exponent would be 2 in this case, so that's my least common multiple. Okay? So how would I make my first denominator here? There we go. How would I make my first denominator 8a squared? I would multiply it by 8, which means I have to multiply the top by 8. And then what would I do to the second denominator? I would multiply by a. I would get 7a. Top. Okay, one thing you have to remember is that there is subtraction going on between them. So now I'm just going to, since I have like denominators, I can subtract the numerators, and I would get 25a. Yep, they are like terms, so I can subtract them over 8a squared. Hopefully what you see is that you can cross out one of the a's,